My bad. I'm a minute late. I've been talking to the starting soon screen. Well, hold on. Whoops. I've been talking to the starting soon screen for a solid minute now. I'm sorry about that. This is another testament of me trying to get myself together. I was eating dinner and we had this hot one sauce, the last dab in the office, and I decided to put it on my salmon. And let me tell you, I already knew it was hot, but it tastes really good. Like I remember it tasting really good. Put it on my salmon, put a little too much on. So I've been struggling for the last few minutes trying to get myself together. And that's why I was speaking to the starting soon screen for a little while. I thought I was good to go. Sorry that I'm a minute late. Because of that, I got my iced coffee here instead of my hot coffee. We do still have a LaCroix on deck, but LaCroix doesn't work well when your mouth is on fire. Hot tongue plus TV static doesn't equal a good time. So, what are we doing tonight? Happy 7th week of Intro to Python Bootcamp. Welcome. Hope everyone's doing good. How many people had off today? I had off today. Today was a long day though, still, for President's Day. So I'm happy for anyone who got a little bit of rest today. Off all day. I'm jealous. I mean, I was off. I actually did work for I worked for 2 hours. A bunch of people from my team worked today to get a float. We can get floating holidays. So people work today to kind of get a kind of an open day without the customer. So I helped out with a problem that we are working on. So I worked for 2 hours. But other than that, kind of just took care of some important things. Yeah. So I'm pretty well rested, I guess. I'm just coming back from the gym. That's why I was rushing to eat, and that's why I was scarfing down that hot one sauce. And man, I'm almost recovered. I am almost recovered from it. That's true. Yeah. Unfortunately, today was a bit of a drain. I don't want to be a Debbie Downer, but today was a bit of a drain. We actually spent the first half of the day kind of with I think I told you guys before that a couple of weeks ago that we had to take the dog to get a biopsy. She did in fact have cancer. So today we were spent some time at the, what are they called? What are the cancer doctors called? Well, we were there. We were wherever the cancer doctors are called for dogs, just kind of talking through some of our options. So that was oncologist. We were at the oncologist today, and it was a lot for the morning. But other than that, it was all good. I still got to relax a little bit. I still got to get some stuff done. So we're all good. But tonight is going to be exciting. We're diving into some more Python. What do we have tonight? I think tonight is a few more tools to add to the tool belt. I think we have some extras, not extras, but some cool things that'll give us a little more flexibility over the stuff that we're doing. But yes, we are on errors. So actually I don't know why it wasn't in here, but tonight is actually modules, errors, handlers, and file operations. So we are going to be going over modules first tonight, which is very important. It's a very important piece of Python. This is how you kind of use from other languages. If you think about libraries or packages, this is Python's version of those things, a way for you to use your code elsewhere, to use other people's code in your code. But what's up, everybody? What's up, F Momo? What's up, Nameless Thug Zero? All good. We already knew. So today was just today wasn't like the find out everything that's going wrong. Today was just, I don't know. We've already mentally gone through the hard parts. So she's in great spirits. She's feeling great. Like she's not struggling yet. So it's all good. It is. I've had pets before, so this is it sucks, but it's not. It's life. Cancer. You know that? I think I told you that. I'm sure I told you that. Yeah, it's all good. It is all good. But whoa, what is this? We got some interesting formatting here. Where's that coming from? If we do, I don't even know how I made that happen. But yeah, we're gonna be going over some errors, exceptions, handling, and then some file operations. So in Python, in your programming languages, an important part to be able to build out really, really good applications is for you to be able to manage files, be able to read in information and write information if need be. So we're gonna learn how to do that tonight. Probably a little longer than best friends. Yeah, it does suck. It sucks a little bit because this is my first dog. I got it right out of college, or like right at the end of school. Well, at the end of my fourth year of school. So not really at the end of school, but at the end of my fourth year of school. I've had her since then, so it's a little bit sad, but she has a great life. Yeah, it is interesting because it's a little bit different because it's my first dog rather than like my family's dog. But hey, all good. You know, you know about this day when you get when you pick up your pet originally. So it really is all good though. People have been reaching out. People have been really kind. But yeah, we're just gonna have a little bit of we're gonna have a fun. We're gonna make sure that she just is comfortable. We're gonna have a lot of fun until she starts doing pretty bad. Yeah, deep dive on life. We'll dive in. We'll have some life conversations. I'll try to reserve those conversations for Friday. Again, I am streaming this Friday. We'll play some games. Just sit around and chat. Feel free to come through. These will be office hours per se, or just some time for people to ask questions. You know, we can literally talk about whatever. Same time, probably 8 maybe I'll probably get on a little bit earlier, probably a little bit longer since it'll be pretty chill. I don't get an opportunity to play a bunch of games nowadays, so it'll be nice to give myself a little bit extra time. So I might go live around 7 or something and just kind of stay on for as long as people are around, just playing some games, just like I said, relaxing, talking about whatever. People have questions about tech, the industry, questions about things that we've been working on, whatever. I think giving having some time to just kind of unwind at the end of the week, unload on some things, have some conversations, I think it'll be fun. So we'll try to do that every couple of weeks. I think will be fun to do. So cool. I'll definitely tweet out about that and probably put it on LinkedIn and Instagram. And I don't know if I can send messages through here, but maybe here as well. So we do have slides tonight. Let me get you all those slides. Let's see. What are we going to drive? Right here. Actually, let me just not sign in again. Make sure I have all the latest stuff that I need. We'll get in here. What games are you gonna be playing? So that's a good question. So I think we're gonna start off. I'm gonna give people time to get on. I'll probably start off playing something random, not random, but something I really like Overwatch. So I'm gonna play some Overwatch, so you guys can watch me be bad at that. But I think once people kind of tune in and people are kind of give people some time to get on and find out about it, since there's gonna be a lot of people who aren't gonna know that I'm doing it on Friday. I think we can play some games together. There's some Jackbox games. I don't know if anybody's ever played Drawful, but we can I think 7 other people can hop in to the game as well. I think that would be fun to do something like that. There's a bunch of stuff like that, but yeah, I mean, I don't know. I'll probably maybe I'll play some I don't know, like Rocket League or something. All the games we can play, I'm pretty bad at. So it'll be fun. If anyone has any games they would like to play together, I'm down to play a game together with people. So yeah. Not derail anyone to use Jira. Yep, we use Jira. Thoughts on embracing Scrum Kanban for those new to the dev world from a net DevOps perspective. So that is an excellent question, and I really love these kind of questions because these are the intricate things that kind of go on in the development world. One, Jira is frustrating, but Jira is also kind of the best at what it does. It's really weird. There's no really great product to kind of handle the Scrum, Agile, Kanban type stuff. If you just want to do Kanban, you could use something like Trello, which Atlassian or Jira also owns, but it can get really weird. I do think it is something. I think it's something that you should embrace. It's something that you're like that Scrum Kanban type thing is going to be interesting everywhere. But I like that you put Kanban in there. DevOps and kind of operations type tasks, DevOps-y operations type tasks are always tough to kind of stick into a Scrum Agile workflow because of the nature of it. It's not always easy to track. Things come up. It's pretty difficult sometimes. So a lot of times the Opsy, DevOpsy, infrastructure side of things operates in Kanban because it's a little bit easier to kind of work through and kind of take the flow kind of as it is. But yeah, I would highly recommend embracing these topics, again, diving into Scrum and Kanban and kind of understanding that, because you will face it sometime in your career for sure. I'm head around Scrum and sprinting versus continuous Kanban. Yeah, it is very interesting, and until I saw it in practice, I didn't really understand it either. Yeah, we can definitely have a bigger conversation about that. We're gonna get going on the stuff tonight, but I like that. Hold that question. If we have some time at the end, we can have deeper conversations about that. If not, bring like that. Those are the kind of questions I want you to bring to Friday. If you can hop on, or maybe I'll copy these down so that I can make sure I address them. And then sometime maybe you can go back in and kind of check it out if you can't make it, to kind of just talk about that stuff more. But those are great questions. I really like those questions. So tonight we are doing these things, and let's go ahead and get you all a nice little linky link here so that you can join up and take a look and follow along at your leisure, whatever I think it's leisure, but I've heard people say leisure. I don't know which one's right. Anyone with the link, copy it. I've heard a lot of people say leisure. A lot of people. All right, so there you go. Got the link now, and now we're gonna get going. Because tonight is actually a fair amount of things, and we're gonna just be diving into the code as usual, and doing stuff manually and just messing around, actually getting our hands on with the code. So I highly encourage you to follow along. Open up your editor, try to type some stuff in. Again, even if you're going slower than I am and you're trying to wrap your head around something, that's fine. Don't sweat it. We're gonna, we want to practice the things that we're learning. Focus on the concept, the high level concepts. The concepts themselves, at least in this unit, should be fairly easy to learn, or at least to understand. Shouldn't be too complicated to understand the concept. It will take practice to learn how to use them effectively and understand the syntax and things like that. So again, I want you to understand the concepts of these, and then we can always learn how to do the syntax and all that stuff. So a little bit of I debated putting in this GIF or not, because we don't want any innuendos here or anything. But I mean, it's the perfect one for this. Modules. First thing we're gonna talk about is modules, and modules are external code. It's an external code file or library that contains variables, functions, and methods you would like to use in your program. So the key word here is external. The keyword is external. So all a module is in Python, you don't have to do anything special to create a module. You can utilize any of the variables or functions or methods or classes in another Python file that is available to you if you import it. We're gonna talk about imports, but again, modules are, think about packages or libraries. There's external bit of code that maybe you wrote, maybe someone else wrote, that you want to use inside of your code base, inside of another file. A module will allow you to do that. So just like the image here, kind of passing along a package is kind of what a module is. So creating and using modules. I think modules will get a lot simpler as soon as you see us do it in action. But creating and using a module. Creating a module is very simple. In Python, it is simply creating a Python file. So if you create a Python file, you can actually use that information. You can use that as a module in another file if you need to. To use these modules, we simply import them into another Python file. So let's go ahead and right out of the gate, let's hop in and let's do some modules. And it's very good to start to understand how to use modules, because you're going to be using modules a lot in Python. Again, they provide a lot of functionality. This means because you can now use other people's code or code you've written elsewhere, this saves you a lot of time, because you don't need to re-implement things. You can take packages and things that other people have already created for you, and you can import them and use them yourself. So let's hop right in. Let's go to our folder. I will have you all know, you see me struggling to type night by night, but I've been doing, I told you guys I was doing Ratatype, and one of the goals I had for this year was to increase my typing speed, my touch typing speed. I'm trying to get up to 80 words per minute. I have my introductory, so I can type relatively fast now if I'm looking at the keyboard, but right now my microphone is directly in front of my keyboard. So that's why I kind of struggle night to night, but I'm trying to learn how to be a better touch typist. And my initial run of typing speeds. I was doing type racer and some other stuff. Was anywhere between 29 and 31 words per minute. I am ecstatic to tell you that right now I'm in the high 30 range right now. Every time I play, I'm in like the 36 to 39 range. So we're making progress. We're still early in the year. I'll keep you updated as we get along. Once I get into the 40s and 50s, maybe we can do some type racer stuff on Friday as well. I'm getting there. I'm getting better. It's tough. I'm breaking years of terrible muscle memory. But yeah, just wanted to tell you that because I was proud of myself. Felt good. All right. Let's see. We're going to Python. Okay. And let's make a modules directory. All right. So here's what we're going to do. We're going to make a file. We're going to call it mod.py. So the name of your module will be the name of the Python file by default. So it's important that you know the name of the file, but we're gonna go ahead and create our own module. So let's take a look back at our slides. Modules can contain variables, functions, and methods. So again, it can contain more than that. It can contain classes as well, which you don't know about classes yet. So I've been actively trying not to put things you don't know about yet in the slides. But so let's go ahead and put some variables and some functions in here. We don't need to worry about methods right now because I actually don't. We've talked about methods, but you haven't seen how to kind of create them. Yeah, but cool. Let's just make some variables real quick. Let's, again, all the simple stuff. Variable name equals Aaron. And age equals 29. And let's do a function. So how do you make a function? Let's make a hello world function here, and we'll call it hello. And we will just simply, this function, all it will do is it will print out hello world. All right. So super fast, we have a Python file that simply has three things. What three things does it have? It has a variable, which is a string for name, and the value is Aaron. It has another variable with the integer value of 29, which is age. And it has a function here. So these are three different things. We can check the type for these things and they'll be different. But a function that simply prints out hello world in here. So we're gonna just save this. And you can see we did nothing new. We didn't do anything new there at all. So let's make another file called our app.py. All right, so we have a new file, and we're gonna utilize this file, and we're gonna use the code that we just wrote in our mod.py file. We're gonna use that in here. So let's go to the next slide. Actually, no, let's not go to the next slide. We simply import them. So let's learn how to import. Right at the top, all you gotta do is type in the keyword import. All you gotta do right there. And now, so this could be done in a couple different ways. It does depend on file pathing and a lot of other stuff, but keep it really simple. Excuse me. For now, by default, because this module that we're going to be using is in the same directory that we are currently in, I can simply call it by the name of the file. So I can say import mod, and you can see how import turned green because we were running a Python file. And then the way that you can now access the information that is in mod by using mod dot in the identifier. So we're importing mod, and let's look at what else we have. Split this. All right, so this is what is in our module file over here to the left, and on the right, we just imported it. And let's say we want access to name. We want to use that variable that is inside of our modules. So the way that we use that is we want to print it. And so the way that you would do it is you would reference the module. So let's do mod, and then you just do a dot in the thing that you want to reference. So mod.name. So if we print mod.name, because we've imported mod, now everything that's in mod is now available to this file. And if we do .name, we can now access this object here. And so let's take a look at it. Now I didn't mean to do that. I didn't mean to close that. But Python 3, our app.py, and you can see here when we run our app.py, it does in fact print out Aaron. And so, like I said, so we'll keep that. I'll keep it set up like this so it's not confusing. I'll stop going in and out of it the way that I've been doing it, so it's not confusing. But we'll leave it side by side. So in here, we basically imported all of the information that was over here, and we used it right here. So I'll stop there for a second and ask some questions, and we'll go through how to use everything in this file. So let's see. Appreciate it, Ari Winokur, on the hidden solid numbers. I'm getting there. I'm definitely getting there. Which editor is this? It is Vim. It is Vim. How you manage to get the highlighting and colors. Hit the exclamation point and type in Vim settings. And that should give you like I'm pretty sure it's up to date. This will give you access to my dot files, which I need to do. One day I need to show people how to actually like use them. I made them available, but I know a lot of people don't know how to use them. But yeah, well, you can use that to get the same effect. We'll definitely go over that. Will your def function run without calling the function? No, it will not. That's a great question. Easy goodness. Oh no, who asked that? Afrocoder. It will not. So this file right here, there's a function here, but if we were to actually just run this file right here, if we were to run mod.py, let's do it. Let's do Python 3 mod.py. If I run it, you can see nothing happens here. Absolutely nothing gets put out to standard output. Again, that's because this file, it did run. Python did in fact interpret the information that is in here. It interpreted, it set a variable called name, and it was equal to Aaron. It set a variable called age equal to 29. And it did set up, it defined this function definition. It looked at this function definition, set itself up, but we didn't do anything else. So the interpreter just says, hey, we're done. That's why we didn't get an error or anything. We never called this function. Remember, we learned about functions that they only run once they are called. So yes, that is why it wouldn't call. But we can figure out over here how to do that. So let's also just show how we can also print mod.name. Actually, let's just print mod. Let's see what happens when we just print mod. So we imported mod. Let's see what happens when we just print mod. We'll save it, which is not usually muscle memory for me because I usually leave out of it. Cool. So this is something that you've never seen before, but this is kind of Python notation here. And instead of spitting you out a bunch of information, it's letting you know here that what we have here, the type of this thing, this object itself is actually, a module called mod from this file right here. So when I print it out just like that, that's all it gives you. Even though it has access to a bunch of information and stuff, it's a nice way for it to print out for you, to give you some information. You can do more to extract some of the data out if you needed to, but that is how it spits it out. So yeah, so let's print out, we did my.name. Let's leave .name in there. Oh, that's nice. This is really nice. .name. And let's also print out, man, I'm struggling, what is it? Age. Let me just think about what I'm doing. All right. My.age. So I keep doing that. I didn't mean to do that. So it printed out our name and our age. Again, we can access it using that dot notation is how we can access that information in our module. So let's just do Vim again. And this time, all right, there we go. So age, and now let's call this function now. So functions only work when called. What happens if we do, what happens if we do want to call this function? So we could print it, but we don't need to print it because there's already a print statement in this function. If we want to call this, all you got to do, the same way you will call a function normally, the same way that over here, we would do something like, not something like, the same way we would call it over here by just typing in hello with these. The same way that we would call it this way is how we would call it over here. But again, you've got to specify where you're calling it from. So you have to go mod dot hello. And there we go. Let's delete this line here. Let's save this. All right, so we print out mod.name, we print out mod.age, and we are calling mod.hello. So let's see if that runs. And it says hello 29, and then it says hello world. So it did invoke that function. It did actually call that function and run it. Even though they're in separate files, we were able to import that module into our current file and use that information, which is really nice. Why would you want to do things like this? Again, I said it makes it a little bit easier because you can take some other code, you can pull things that have already been created so that you don't have to redo things. You can also use this to do, like, maybe you are writing an application. You can use like a common practice is to use like a shared utilities file. So if there are some main utilities that your entire application needs to do over and over again and that a bunch of different pieces need access to, you can write one utilities file that has a lot of little tools that do a bunch of things that you need to utilize elsewhere, and you can use that to import into other files around your application, which is really nice. But yeah, this is a common paradigm in every programming language. Makes it nice to kind of just package up a bit of code. You don't got to do anything crazy. J Wildman 33, welcome. Thank you for the Twitch Prime sub. Welcome to the family. Glad to have you on board. Cool. I also like that you imported mod instead of import star from mod, which would have imported everything. Yeah. I could do that too, but I'm pretty sure it does. It does import it, like import mod does import everything that's in. Import mod does in fact does in fact import everything that is in this mod thing. If I did the import star from mod, I could. It would do the same thing. It's basically the same thing. If he did import star from mod, he wouldn't have to do. Oh, interesting. This is good. So let me see that. So you're saying if I do import star, so if anyone doesn't know, this star is like a wildcard character, a special character, a wildcard character. It means star means everything. So if you ever see a star, it usually means, almost always, it means everything, including regular expressions, things like that. So if I do import star from mod, let's see. So you're saying I don't have to do the mod prefix and I can just do like name or age and hello. Let's see if this runs. That's interesting. I also didn't know this. I kind of never do this. Yeah. Let's see. Invalid syntax. Did I do that wrong? Import. But let me do it. I've seen imports like this, but I think I've only seen imports like this in JavaScript. So I learned something new today. All right, cool. Well, I'm going to leave it to just import mod for now. We'll mess around with that again. We'll play around. It will be fun. We'll play around. Maybe it's from mod imports. Yeah, maybe it is. Let's try that too. We got time. From mod import star. I definitely don't know where my special characters are yet, so definitely got to look for that. Let's see. You think that's right? Ah, yes, that is it. Okay, that's good. That is good to know. I didn't know. Maybe I did know that. Nah, I don't know if I knew that. I have no idea if I knew that. Well, I know it now, so that's exciting. Thanks for teaching me something new today. S. Why is it Q? All right, Very, very nice. I kind of like that. But I'm going to leave it as just import mod for now. Darn it. I should have commented instead of... We'll leave it at this for now because we're going to go through a little progression now. Mod dot, not mop dot. Also, I just want everyone to know who didn't already know that another reason I struggle with the typing is because I have a whole new layout. My computer layout is different. My keyboard layout is different from like the laptop that I use every day for like work and stuff. So it does make it difficult. Like it's different from the one that I have at home as well too. So like whenever I get back in here, it's tough. I'm getting there though. I'm gonna actually build another keyboard with the same layout because I prefer this layout for home, so that I can get a little more practice, be a little more consistent. It's only gonna suck when I have to actually work off of a laptop, and maybe that just means I'll have to build a portable keyboard with the same layout that I take everywhere with me and be that guy and be really annoying when I whip out a whole keyboard with my laptop every time I want to use it. I have no problem doing that. I will be that guy. I'm gonna be that guy. I will be that guy. If you didn't know, Terrence is he's right off screen. I don't know if you guys can hear him, but
hey folks.
Cool. So also we can name modules. So maybe you don't want to call it whatever the name of the file is. Maybe you want to call it something different. And so we can do that. Sometimes it makes it easier to identify things throughout your code base. So you may want to do that. The way that we do that is we import the module as whatever name we want to call it. So the same way that we have everything here, I can import mod as Superman. And so now though, I would need to reference anywhere I wanted to use mod or the things that are in mod. Again, it's just an alias, so it's just another name for the same thing. I would need to call it Superman instead, so I'll just change this one. So this should work fine, but we should get errors for these two things because again, mod is imported, but it's not referenced to as mod here. It should reference as Superman. Why do I keep doing that? I'll get it right. I'll get it right. I'm trying to stop leaving the app so I don't have to keep recreating the layout. And just put it in the background. But if I run it here, you see my name gets printed because we referred to it via the Superman alias that we created. But when it gets down to the next line, it says name mod is not defined because it's not defined. Because we did not, our app is what we use. Because again, we imported this module as Superman. So very important, just important to know that you can do it. And that if you do it, you need to refer to it as whatever name you imported it as. So again, it's nice. You will use it. It's nice to be able to, sometimes the module you're using, the helper function file is really weird or really long. The name of it could be super long. Like maybe this would be our modules that do stuff. Now, bad name, but you could definitely have a file that was called something long like that, was very descriptive, and you don't want to type that in every time you want to use it. So you can give it an alias if you want. And let's just do it like that. So Superman. And down here, let's just change this to Superman. So now you can see why programming can be a little weird and a little hard to follow because you have a lot of options here. You create a lot of the stuff, the names. Naming is one of the most difficult things to do in programming. It is where things go wrong. So don't sweat it. This is why it can be hard to follow code sometimes. You're like, why the heck is this called Superman? What is Superman? Is Superman a function or something that I'm supposed to know about? Or is it something that this person created? Yeah, it can get weird, but you can call it whatever you want. So any questions so far on that? No, I don't see any questions. So we'll go on to the next thing because again, these modules are very important. So selective import. If you'd like, you can import only what you need. So if you don't want to import everything in a file, you're more than welcome to import only the thing that you need. Following the same method that we just wrote before when we did the from mod import star, we can pick and choose the things that we want to import. So maybe we don't want the variables that are here. Maybe we don't want name and age. Maybe we just want the function hello. So we can take a look at this and we say from mod import. Wow. Import again. We just want hello. So we'll go ahead and import hello. So now, because I've only imported hello, I shouldn't have access to these other two things. So when I run it, these will fail, and this would run, but it's gonna fail in the very first one. But I'll just show you that before we were bringing in everything, now we're just bringing in this hello function. So we're only bringing in this bit of code here. So let's save it, and let's run it. And you can see here it does fail because Superman is not defined. So also, not only did we not import everything, but we also are still using Superman, which is the alias. So let's fix that. And let's just comment these out because these will not work. And because we called it from mod, we'll just leave it like this. So mod.hello. Oh, this sucks, because then if I go back to, okay. Mod is not defined. Oh, whoops, sorry. I didn't need to do that. Mistake. You do not need to call the name here. You just need to, if you import the individual function, the same thing we were talking about before, you can just use that function. I imported hello, so I can just use hello. So I just call hello and I can use hello world. Again, I've only imported that one thing. So if I try to, let's say I did try to use name. I did not import name, but even if I try to print name without importing it, name is not defined. You can't do that. So you can be explicit about what you import. And I think you can do multiples though. Like I think if you just want to, I think you can do it like this. I can't remember what the syntax is. I know there's a way to do it. But yeah, so that works. You just put a comma in between if you want to import more things. If you just want to be very explicit about the things that you're importing. And again, let's take a look at our module. This stuff over here. You can also, I believe you can also still give this an alias. So I think you can do as X. And I think you can just do, I believe you can do this, maybe wrong. So I think you can import one single thing and still call it something else and refer to it as something else. Let's find out to be sure. You can. So you can kind of combine those things together. So the keywords you want to know. You want to know the import keyword. So import will allow you to pull in information from another file. And then you can refer to that file name. So I could do like import mod and maybe show you. So that's one way to do it. That's probably the most standard way to do it, to import everything in the file. Or you can import individual things from a file, so individual items like functions or variables that you want to use, but you can also use the as keyword, the from and the as keyword to be able to set up aliases, to be able to call these things something different or refer to them as something different. Imports can be very confusing in the beginning. Again, the high level concept of just knowing that you can pull in information from another file, I think is a relatively easy concept to understand, but like, like realizing like this is something different from this, and like what does that actually mean, can take some time. And again, I encourage you to play around with it. I encourage you to try to import a lot of things. I encourage you to import individual things that you need and just kind of practice that. Even if you just set up a file with a bunch of variables, maybe you just set up a module file, and all it does, maybe the next time you write, you try to solve one of those coding challenges, maybe you just write a file that, again, a mod.py file that just all the variables you're going to use, maybe you just set up all the variables in there. And then you import them into another file where you're actually solving this coding challenge, and you can practice it that way as well. But again, not a tough concept to understand, can be a tough concept to master. All right, so selective import. So we have already made it through. It's 8:42. We're making good time. We've already made it through modules. Any questions on modules before we go on? Again, high level concepts are what I want you to get out of it. Ask away any questions that you still may be fuzzy upon. And then after this, practice. After this, like, definitely try to practice. Just Google some modules. At the end, I'm going to give you a link to, there's a fair amount of built-in modules in Python that you can import and use at any given time. All the other modules, any other kind of modules, you'll have to download and import them. Again, they can be at different file paths. But yeah, it's pretty cool. We will definitely, as we are going along, as we get into the next algorithm section, as we are building out different things, we're building out both of our projects, we will be using import, so we'll get practice with all of those things. All right, cool. Let's head on to errors. So errors can be very scary. Yeah, they can be kind of scary. Error, like when your program breaks. Right now, like this is an error right here. You can see a name error right here. These can be scary, and they can be hard to understand. They can be hard to trace. They can be hard to debug. But errors are valuable parts of programming, and you will encounter them. So we are going to learn how to identify them, learn how to manage them, learn how to handle them when they do pop up. So in Python, as in most things, you have many different types of errors, but here there are categories within these, but there are two main types of errors for Python, at least. The first one of which is a syntax error. So syntax is just when you don't follow the rules or structure of Python. So again, if you're missing semicolons or missing parentheses or quotes or something like that, when you fail to adhere to that structure, this will give you a syntax error. And Python will in fact let you know that you have committed syntax treason. So let's go back. Let's make an errors directory so you can see that. So vim syntax dot p. Where's the y? We're gonna get the y on the first try. Yes, we did it. All right. So syntax error. So maybe I do something like def greeting and open close, and I just say hello person. Let's print. Let's return hello there. Cool, and then we'll call it down below. So we'll just call greeting. Cool. So we have this file here, simple file here, and we can run it with Python 3 syntax.py, and it ran, but it didn't print out anything because we did not print this. We just returned it. So let's print it. Let's print this greeting out to the screen, and it runs. Everything is looking good. That gives you anxiety. I'm sorry about that. My bad. I was being a little edgy with the GIFs this time. Maybe I'll pull back just a bit next time. Definitely being edgy. All right. So what if I left off again something like that? Python needs to know when that line is kind of done. So we'll pull that off and look at this. We get an actual syntax error that lets us know that there is an error with our syntax. We are not following the rules. The structure is not quite correct. Invalid syntax. So it's when you see that, just know, when you see syntax error, just know that you probably messed up something. So you probably left a character off. Like if I was to, not close those quotes, run it again, we still get syntax error, end of line, while scanning string literal. Again, shows you where it is, lets us know, what file it's in. And right now, these errors are fairly simple. When you have larger programs, the traceback, the error that you're going to get is going to generally be larger, especially when we get to these exceptions next. But syntax errors, again, it usually lets you know right where it is. So if you see that, just know you probably made some type of simple mistype or character mistake, and just be diligent about going in there and check in to see what's going on. Again, it should tell you where it is. All right, so that is a syntax error. I thought this one was the Trump one. So actually, I don't feel bad about this one. It's definitely yes. So I chose it because as soon as I saw it, I got really uncomfortable because when I grew up, like on Windows XP, Windows 95, all that stuff, like I can't tell you how many times, like not exactly like this, but you could easily go to a stupid website and get the JavaScript pop-up hell, which is super annoying. Nowadays, not really a thing, but it was definitely a thing. So cool. That is a syntax error. So make sure you're following the rules and the structure of Python. So the next type of error, this is exception. So underneath exceptions, there are a bunch of different type of exceptions that exist. But right now we're just talking about exceptions as a whole. So syntax errors, again, not following the rules or structure of Python. Exceptions are syntactically correct. So the syntax is right, but the error occurs during execution. So whenever you run into an error while the code is running, that is an exception. That's what they're referred to as in Python. So let's take a look at that. What might an exception look like here? Again, maybe this greeting takes in a name and an age, and maybe greetings from the future. We're gonna call this greetings from future. So we're gonna rename our function. It's called greetings from future now. And what it's gonna do is it's gonna take in a name, and it's going to take in your current age, and it's going to basically give you a greeting. It says hello name. So let's format this. It's gonna say hello name. It is 2021. We're just gonna say next year, 1 year in the future, and you are age. Let's say, that's not gonna work. I'm gonna have to change this. Age plus 1 years. I mean, this should still give us an error. So it might still be nice. But let's say we wanted to, give greetings from 1 year in the future and let people know how old they would be during that time. Let's do that. So in here, we're going to pass in the name Aaron, and we are going to pass in the age of, let's pass in the age of like 5. Well, I mean, this should still work, but let's run this and see what happens. Excellent. So it failed because this is dumb. Everything I did was stupid. But actually, this is a completely different error than I was trying to create. So that's great. First type of error we've gotten. It's an exception. We get a name error. So this is an exception. This is not your syntax error. and it is a name error exception. It says name greeting is not defined. So let's figure out why we got that. So let's take a look at the error. Let's break it down really quick. Trace back, most recent, call last. You'll see this every time. File, the file that we're working in. So syntax.py is the file that we've created and we're working in. Line number 4 in module. Print greeting, Aaron 5, name greeting is not defined. So let's take a look back at our file. And we try to use greeting here, but look up here. There's no function called greeting here. So you got your first taste. You got your first taste of an error. Not your first taste. We've run into many errors before, but that is one. But let's say we, see our error and we're like, all right, cool. We fix the name here. Let's see what happens now that we, are calling the actual function that we've actually written. Let's see what happens now. And let's see if we get the same error. Okay, so first time we got a name error. This time we get a type error. So can only concatenate a string, not int to string. So this happens. Why does this happen? This happens because this error says, we'll actually look at the error again. Let's get comfortable looking at it. Lets us know again, the file and what line it happened at. So line 4, we'll take a look at line 4, see what's going on. And then they gave us the print, greetings from future, Aaron 5, syntax py, line 2, in greetings from future, return f hello 2021, and you are age +1 years old, can only concatenate. What do we learn about concatenation? What is concatenation? That is the act or the process of combining strings together end to end. String, not int to string. So we try to basically concatenate a string here and a number, and it would not allow us to do that. So we get another exception. So there's a few other exceptions that you can raise, but we're gonna get into those in a second. But just want to show you that those look similar. You have syntax errors, but your other exceptions can be different types. It'll tell you what type of error it is. Type errors, name errors, and we'll dive into the other few that there are in a second. Any questions on that? Most common error is the first version of Win98 before 98 SE. Yep. Syntax, runtime, exception, and semantic. Yeah, semantic errors as well. That is true. All right. So let's take a look at these. So those are going to be the two we're going to focus. Or those are the two types that we're going to focus on right now: syntax and exceptions. But let's talk about how to handle these things. So you can both. Actually, we'll talk about handling them first. So, while errors are good to let you know when the program is having problems, a lot of the times, if you run into an error, you don't want to allow a program to just die because it ran into an error. What you want to do is you want to handle these things. You want to be able to, if you're at the point in your program, your application that you're creating, where this is a good spot to, it might be prone to errors. So you can build in ways to make sure that your application is resilient enough to experience errors, but not break. And so to do this, you can handle these errors. So I forgot to change this slide from last time, this GIF from last time. This is not a good one. This was for the calling functions thing, but we can keep our programming running. If not is, let's go ahead and fix that right now. Fix errors as you find them. If we run into an error, but handling that error, oh man, I was struggling during this, obviously, by handling that error or exception handling. It's called exception handling. It's called exception handling. So we can handle those errors. We can do this by trying to run the code, and if we receive an error, we can tell Python what actions we would like to take. So there are absolutely times where you do want an error to stop your code, which we're going to get into after this. But there are also times where we want to try to make something happen. We want to test to see if that code will run. But if it doesn't work successfully, we want to be able to take corrective actions or tell the program what to do next. So how do you do that? That is with the a try block. You'll probably hear, you might have already heard, but you'll hear try catch blocks. In Python, it's try an exception, but it's a try catch block. So you're basically going to try a piece of code. You're going to try to execute that code. If it should fail, you are going to catch it, or you are going to you're gonna catch that that failure. You're gonna catch that exception, and you're gonna do something with it. So let's do a vim except. Let's do try. We'll call this try catch.py. All right. So maybe we want to do a function called add. So we're just going to add some numbers together. It's going to take in num1, we'll take in two numbers, num1 and num2, and it's just going to add them together. And so maybe it's going to do return. We want to be able to add them together. So even if someone passes in as a string, we want that to work anyway. So we'll try to do some type coercion or type casting. So we'll do int, return int num1 plus int num2. So why are we doing that? We're doing that because maybe we want to account for people, passing in strings of numbers instead of just integers. So we'll try to cast it to an integer, and we'll try to add them together and return it. So we know that let's do a print. Let's run add, and let's pass in the number 1 and 4. So that should give us back 5. Let's run that, make sure we're good to go. So Python 3 try catch. All right, first thing we get a syntax error. Why do we get a syntax error? Line 1, take a look here, def add. What did we not do? Again, we're doing errors. So we forgot to put the colon there. So put the colon there, good to go. We've learned how to, these can be helpful, while you're developing, but they can also be very annoying. We run it, we passed in 1 and we passed in 4, and it gives us 5. Everything is looking good right now. That's exactly what we want to happen. So what happens if we do let's make these strings now. So they're integers. Let's go ahead and make 1 a string and leave 4 as an integer and see if this still works. Do you think it's going to work? I'm hoping it will, because we are casting to integers up here. So let's see what happens. We do it, it still works. Great. And let's make them both strings. Come on. Nope. There we go. All right, run again. Still good. So it works for strings and integers. But what if we pass in something like 1? What if we pass in words instead? What if the person passes in something that can't be converted to an integer? So just in case you didn't know, when you try to cast a string to an integer, when you try to type coercion, when you try to use type coercion and make it an integer, or make it be evaluated as an integer, it's got to be it has to be a string that is actually a number for it to work. So this should actually fail. So let's see what happens when we run this. And now we get a third error. So we've already seen type error. So when we can't, do things between two types, you cannot concatenate a string and an integer here. We also saw name error. So when something is not defined, we saw that as well. So those are 2. Now we're seeing a new one. Error still looks the same, kind of lets us know where it is, lets us know what line the line is that actually caused it. Invalid literal for int with base 10 1. This is basically just telling us that we are unable to convert this. We're unable to cast this into an integer. This string into an integer, so this will not work. So we get another value error. But what if we want this? What if we wanted this code to not fail? So maybe if we didn't want this code to fail, maybe we say we can use these try blocks. So instead of returning, actually, so can you do it? I think you can do a return and a try. You just use this try keyword. So this is kind of like a if else. It's very much like an if else. So it'll say, if this works, go ahead and like try this code. If it works, go ahead and, do that. But if not, except if it doesn't, do something else. So if it doesn't work, I can say print, hey, you need to enter a number. You need to enter a number. So it's going to try to run this code here, and if it works successfully, it'll go ahead and it'll do that. If not, it'll go ahead and print this out. So let's go ahead and actually I'll make this a return as well, just so it's the same. And I didn't close it. Wow. All right. Also, what's up? AxeP603, welcome. Thank you for the follow. Glad to have you as a part of the channel. So we'll do this Vim try catch, Python 3. And because we didn't change the numbers, we're passing in this number 1. You can see here that the program did not fail. It did not error out. The status code of this is actually a successful run. But it says, hey, you need to enter a number. So this is really great. The code failed and it let us know what to do. So if we go ahead and we change this, so maybe actually let's make this a little bit better. Let's add num1 and num2. Let's ask for input. So it's just a little bit cooler. So we're just adding in the things that we've learned before. So let's ask the user for let's do num1 equals input, enter first number, space right there. So num2 equals input. Let's have complete input. Yes. Enter second number. What? There we go. Oh. Ah. All right. So we're going to take 2 inputs now instead, and we're going to go ahead and we're going to, instead of just putting the numbers in, we're going to enter them in. So let's go ahead and do that. Run it, enter first number, 4, 6, and we get 10. So that looks good. That looks really good. It looks like our application is doing what we want it to do. Again, we could try it again with something like 90 and 92. We get 182. It's adding our numbers together just fine. We'll run it again. Let's say we put in 90 and we put in 100. It's failing. I thought that should work, but it is failing. It says, hey, you need to go ahead and enter a number. So it didn't fail out. I wonder why that didn't work. Well, these are strings by default anyway. I wonder why that did not work. Take them, pass them here, int1 and int2, num1 and num2. I wonder why that didn't work. I'm actually very interested to see why that didn't work now. Did I make a mistake? 90, 100. Anyone know why that didn't work? I actually don't know why that didn't work. Let's see. I coerced it into an integer. What's an integer? Yeah, they are strings, but yes, they are strings and not ints, but that was the goal of this right here. This was working before. Like if I actually pass in strings right here, it will work. It will work. I'm wondering, it's interesting. Should work. Input is a string by default. Yep. I agree with you. I'm there. I'm with you. But why is it not being coerced? Why is it not being casted to an integer? Why is this failing? The quotes make it unable to convert. Because that makes sense. Because it's already a string. Yes, because it's already a string and I'm actually passing in quotes. I gotcha. Okay, that makes sense to me. Thank you. I needed some clarification there because I was worried. So needs to be a number. Great. We pass in the numbers. Let us know that it needs to be a number. Again, if we try anything else, we try to pass in stuff like this. It says, hey, you need to enter a number. So that is what a try catch block does. You can also do or try except block. Again, you don't actually have to do anything with this if you didn't want to. You could do something like pass. You can use the pass keyword and you could just say, hey, do nothing. And if I try to do this again, type in things that are not numbers. It basically just gives you this none and it just kind of passes through and passes through and does that. So you don't need to do anything. It just makes sure that the application does not exit in an error. So you could pass if like you weren't really worried about the error and you wanted to, maybe you were processing a bunch of things and it was okay that you knew there were going to be errors every now and then. You could do that, but ideally you'd want to handle them in a certain way, and that's how you would do it. So that's how you would handle that's one way to handle an error, and that's generally the way that you would do this. So again, it takes some time to know at what point in your code this would be a valuable thing to do. You don't want to just put a try catch around the entire thing because then you don't have any insight into what's going on, and the application will always succeed even when there are problems. So it takes a little bit of time to know, when and where to do things like this. Also be careful with these try except things. You should be building your application as you're getting better and better. You should be building your application in a way that you don't need a ton of these. You shouldn't be reliant on try except blocks. They can make things very difficult to debug. I've seen big problems go unfound for very long amounts of time because these try excepts were in there and they were not properly doing anything when it did run into an error. So it can mask issues with your code. So I would be careful when using them. Only use them as necessary. Yes, I like that, and we're about to go into raising exceptions as well. But yeah, exception as e print error. Yep, you can print that an error has occurred for sure. If you want to track that, if you're logging, we're gonna talk about how to push out to files in a little bit. But like if you're logging something, you could put that in there. But you could literally do tons of stuff in here. I'm gonna leave that there. We'll get there in a second. So that is handling errors. So we talked about the couple different types of errors, and now you know how you can handle them. And it takes a little bit of time to get good at them. But you can also throw an error when something happens. So maybe you have some code and you don't want it to continue processing when something happens, but it doesn't necessarily, the thing that happens doesn't necessarily break the code. It doesn't cause a Python exception. It doesn't cause any type of runtime problems or any syntactical problems. You can using the logic that you create, raise exceptions to kind of stop the program from running if you need to. Why did I put this here for a reason? I put this here. Was this supposed to be? No, hold on. This was supposed to be somewhere very specific. This was supposed to be. No, it was here. It was supposed to be here. It was for locking, or was this for a different night? I can't remember if I forgot to change a lot of these, maybe. Yeah, okay, that's what it was. I copied and pasted the slides. Like I consistently copy and paste the slides and rework them. I think these were for, I want to say this was for last night. I want to put some context around it. I think it was for like locking down like your VPCs or something in Amazon or something, I think. So sorry that the gifts are wrong. We'll change those so that you're not confused. Yeah, because this was for scoping. That was from your last Python one. So if this was for scoping, this was for, I don't know, this was for something, but it was for Python. But exceptions, raising exceptions, you can use Python to throw one of those exceptions, errors for any situation that you define using the raise keyword. So yes, and actually, let me send you the W3 Schools page for this, because again, I think W3 Schools Python tutorials are actually excellent, that you can use to put some context around some of the stuff that we're doing here. W3 Schools. I'll just send it again. I need to just put W3 Schools in the link. Learn Python. W3 Schools is great. The only problem with W3 Schools is I think it's more helpful after you already have a handle on one coding language or programming language and kind of those base concepts. It gets easy after that to use, but I think it doesn't. I actually think upfront it doesn't always add enough context. What's up, Pylang? Welcome bootcamp. Slides are made up and the gifts have no point anyway. I love it. I love Who's Line. Some nights is like that. I like that. Maybe I'll just start putting extra random ones and see who can come up with the best connection on why it mattered. I like that. How much Python do you use in DevOps? Right now, I don't use a lot day to day, but most people use a lot. A massive amount of automation is done via Python. Yeah, I mean, but you can also use pretty much there's a lot of different languages you can do. I probably see Bash more than I see Python, but Python is it can be heavily used. A lot of places that are doing infrastructure automation, things like that, do utilize Python to do those things. Yeah, so Python is, it's also just such a good general purpose language. It's just good for so many situations. Yeah, it's good for so many situations. So we learned about try except, but let's take a look down. So you can have, actually, this is good. I'm actually glad we went here because you can do kind of these if type things based on the type of error it is. So you see here, they do a try and they do an except, but they do an except for name error. So you can set up a try catch based on, or a try except based on the type of error that is returned. So for the syntax thing that we did, like if I put in name error here, this actually would not work if I put in incorrect. This shouldn't work if I put in incorrect things here. Yeah, so you can see here it actually spits out an error because the error is a value error. Before, it was catching that error and the program was running fine, and it was just kicking us out a nice little message saying, hey, you need to enter a number. Here, it's actually running into a genuine problem, and it is actually erroring out and it is stopping. And that is because in here, you can accept based on what type of error it is. So maybe I want to be very specific and say, hey, only continue along if it's a value error. So we know we were getting a value error here. Let's run that again. Type some stuff in. And this time it did not spit out an error. It handled that error accordingly because we told it what to do when there was a value error. If we were to create a different scenario where we were running into a name error or syntax error or something, then this would actually not catch that thing. So that's important to know. And again, you can have more than one of these things here. So I could have a block for also like a name error as well, if I wanted also syntax error, but I could also just have like a else block. So this is almost like an if, else if, else, like this is like an else statement if you want to be able to do that. So I'm glad we went to this site so I can show you that. Yeah, cool. Yep. So any questions on handling exceptions, any questions on the flow of tries and accepts and how they work? So else, if it's not a value error, say you done messed up, Aaron, exclamation point. So yeah, you have some options here for what you want to do. Yeah. Any questions on that? Challenge accepted. I like it. So you know what I'm gonna do? I'm putting it in my Google Keep right now. I'm going to make exactly 20, well, maybe not exactly because it might be an odd number. I'm going to do 10% of the slides. 10% of the slides will have a meaningless GIF attached to them. And I really want people to discover those and send in what their best answer on how they connect. They probably won't, but I'm interested to see. How to handle nested exceptions. What do you mean by nested exceptions? Are you saying like, try this? So we'll try this. And then instead of returning, we'll try to do something like new number. So instead of returning the value, we're gonna set a new number. And then maybe we want to do something like if try new I'm trying to think of a way to make this break, or like for me to be able to make this break. You can do this though. I can say try new num times 20. I just don't know how to make this fail. Except return nested failure. Now, you can do this. I'm not sure how. I need to think of a scenario really quick where I can make this fail, but let's go ahead and let's run this really quick. So if this works fine, if this try works correctly, it'll drop into here, and then we'll try to run this. So let's see. You see, goodness, it's just like if and else ifs. So if I run Python 3, whoops. I got my first error because of this. And run it, and 56 plus 23. And instead of returning them added together, they end up multiplying because, again, these are very much like if statements. So like if this is true, go ahead and run this. It says, hey, if this returns good, go ahead and run that. So this works successfully. But if you want to see it fail, we know this is an integer. Maybe we want to, how do I make this fail? Maybe plus concatenate it with something, int plus hello. So this will now fail. Run it, even if we enter in real numbers, it fails. Nested failure, because you cannot. What kind of error would this be? What kind of failure is this? This is we're trying to basically concatenate an integer with a string. We are going to get a type error here, and so the error that's raised, nested failure, is raised. So you don't need to. So yeah, it works very much like an if statement. So you can nest them if you like. But you can also raise an error. So instead of accepting, I can raise an error. And that doesn't need to be a part of a try. I actually don't think it can be a part of a try. Where's raise in here? Raise an exception. So yes, so I'm not going to put it as a part of the try. I can put this manually inside of one of those blocks if I want. But again, a situation in which you specify. Let's look at the slide again. You can cause Python to throw an error for any situation that you define using the raise keyword. And so I can say, hey, if x is less than 0, go ahead and raise an exception with this error here, and it'll actually kick out a real Python exception for you. So these are good because maybe your application, again, maybe you have a very important business requirement where your application is ingesting some data, and this data needs to be it needs to be super clean, and it needs to be very consistent, and it's a bigger indication of a much larger problem if maybe a data type isn't correct. So maybe, I'm going to delete all this. And maybe even for this input, maybe information is coming into this application. And maybe the first thing you want to do is you want to say, hey, instead of handling it with type correlation, maybe I want to say if type of num1 is not equal to int. It's not equal to int. So this is just a normal if statement. Go ahead and raise exception. I'll spell exception wrong. Say, hey, comma, num1 needs to be a number. So you can create the scenario. You can create the scenario for a runtime error to happen. So if we try to run this, the first number, I'm going to enter it in just fine. And actually, I didn't expect that. Let's see. Did I not? What is? Hold on. Maybe is it just int? If I do Python type of because it comes in as a string. Never mind. That makes sense. Okay, makes perfect sense. I still need to handle it. That's fine. So it fails. This exception is raised that you see here. The exception is raised because, again, we know that for input, it comes back as a string. So I'm checking for type. I'm checking for the type here, and I'm checking for int, but it comes through as a string. So this exception is raised. So like if I wanted to make sure, just so you can see it, I think type of string is str, not string. I think. I'll check types in a second if this does not work. So type of a string is str. Is it not how you check against? How you check against a string? Can I not do it like this? Anyone know? Python and DevOps, Google, Fabric. So that's funny. Python Fabric. Python. So Fabric's interesting. I'm actually very interested. Someone brought that up. What's up, Amir? Fabric is very interesting. We'll talk about that in a second. How do I don't know. How do you check against the value of type? I don't know. I don't know how you check against the value of type, but again, you can see here, we could check that. I don't think it's important right now because we still have some other stuff to get to. But or I can say if num is not equal to 60, num1 is not equal to 60 or something like that. We could do that. So unless num was, we'll make it 60 this time. It is equal to 60. It's not equal to 60. Oh, so I gotta make it in. I failed at doing that. And I couldn't make it anything else. What? Num1. What am I doing wrong here? I'm confusing myself. I think I'm going too fast. Type. I'm checking for type. Okay, that makes sense. Got it. I know what I'm doing now. I know what I'm doing. So if I make it anything other than 60, it should raise that. But if I go ahead and make it 60, whoops, I messed that up too. 60. What's happening here? Is not equal. If num1 is not equal to, it's a string. I'm struggling. I just want you to see it not error. You see an error every single time. There we go. Yeah, so if I make it anything other than 60, it will error. All right, cool. So now you saw not error. I don't know why. I didn't need to waste my time going through all that, but all good there. That is how you raise an exception. Again, you can manually use using Again, using the tools that you've learned, using your conditional statements, using your comparison operators, you can create a scenario for these exceptions to be raised using the raise keyword, and that can be very important for the workflow of your application sometimes. So that is cool. Raising exceptions, and then file operations. This is fun. We'll just mess around with this. We actually have plenty of time. File operations. Let's knock this out so that anyone who wants to get out of here can get out of here, and then we can go over all the questions and just chat afterwards. But let's talk about file operations. So in Python, you can create, read, update, and delete files. This is very important. It's important for us to also know this because we're about to learn how to do some automation on Wednesday with Python. And again, you can, being able to do this really helps with that. It helps you be able to deliver, keep track of information where needed. So let's go ahead and let's learn, about the various file operations that you have in Python. So we're going to use W3 Schools for this. We're going to use this because I think their syntax is good. They have a whole file handling section. And I was going to make some slides for it, but I thought it would be better to just go through this together and then refer to this, because file handling is a little more complicated than things you're used to, just because you're going to have to use some outside functions and things to be able to do that, or not outside, but just functions you're not used to. But let's talk about file handling and file operation. So the key function in working with Python files is the open function. So open function takes two parameters, the file name and the mode. So if you want to open up a file to be able to do anything with it, whether it's to read it or write to it, you need to use the open function to do so. So we're going to go ahead and learn how to use that open function. And then there are 4 different methods here, 4 different modes for opening. This is important to know, but you probably won't use many of these up front, but sure, we'll go through it. So read. This is the default value. So you actually don't need to specify anything with the open function up front. If you don't need to, read will happen by default if you do not put anything. So it'll open a file for reading. It'll error if it does not exist. So we'll look at that in a second. Append. Important that you know what append means. It opens a file for appending, creates the file if it does not exist. So appending, what does appending mean? Appending means adding something to the end of where it already exists. So if there's information already in this file, it will go ahead and it will start adding to the end. Appending is good for things like logging. So append can be great for a lot of different things, but especially for things like logging. And note that it creates the file if the file does not already exist. This is kind of nice. This can be nice, but also there's some pitfalls to this as well. Right, it opens up a file for writing. So appending is the same thing as writing, but again, it's adding it to the end. Writing will go from the beginning of the file. It creates the file if it does not exist as well. X for create, this creates a specified file, returns an error if the file already exists. So this just creates, this writes, this appends, this adds to the end, and reads the file. In addition, you can specify if the file should be handled as binary or text mode. So most of the time it's gonna be text mode. Binary is for things like images and other file types. So let's take a look at how you open up a file. Let's create a simple file really quick so that we can look at it. So let's take a look at what they're doing here. They're setting a variable of f, and they're setting that equal to open demofile.txt. So that's basically going to open up this file, and it's going to dump the value. It's going to dump the contents. It's going to open this up to read it, and it's going to dump all that information into F. And now everything that's in this file will now be available via F. So let's take a look at what that'll look like. Let's see if we can do the same thing. So let's go back. File operations. read.py. Wow, I didn't mean to do that. rm dir read.py. I meant to just touch read.py, but let's make a file first. Let's make a file called names.txt. And let's put a bunch of names in here. So James, Sarah, Aaron, Bill, Karen, Bob. Things that are easy to type. Tom, Tish. Not easy to type, but something like Rudolph. That's not how you would spell. That's not how I would spell Rudolph, but that's how we're spelling it today. Frank, Ruby, Tim, John, Anna. All right, so we got a list of names here. We have this text file with a list of names. So just a simple text file. The names.txt file has 14 different names in it that we're going to work with. So maybe our application, maybe the application that we're going to be writing needs to take in a list of names, or needs to consume a text file, needs to be able to read a text file and do some stuff with that information. So let's vim, again, we'll just call it app.py because we don't know what it's going to do yet. But the first thing that they did is they set a variable. So let's make a variable just so it's descriptive here. Let's call it list of names. And we're gonna set that equal to, we're gonna use the open function. So open, and then we'll call the file that we wanna open. So names.txt. Now, again, by default, you don't need to specify anything. It will simply default to read, and it will go ahead and it will read this file. So we can go ahead and check that and just make sure we have what's in it. So we know we have that list of names, and so let's see what happens to what this variable looks like. So names, let's print it out, but let's also first print out the type. Let's see what the type is going to be of list of names. So we can see the value, but we can also see the type of list of names. All right, let's print and see those two things. All right, and okay, name is not defined. Cool. So looks like it failed. Got a name error. It says names.txt is not defined. What do we call it? We call it names.txt. List of names open, names.txt. Let's take a look at this. It needs to be a string. So let's go ahead and put some quotes around it. I was wondering why the colors never changed. All right, so we got two different things here. We print out the type, which is this IO text wrapper. It's this class IO text wrapper, and then we get this, which looks very similar to the module that we tried to print out before. So that's great. It lets us know it's a text IO wrapper of names.txt and the mode that it was read in and the encoding. So excellent. So we can start there. We have a little bit of information available to us now. So that gets sucked into this. Let's take a look at W3 Schools and see if we can break that down even further. What's up, Bib Money? Welcome. Stumbled upon your channel. I work in an optical lab. I've never heard of that before. That's awesome. There were thousands of Excel cells that I need to comb through in order to create PF criteria for the products I'm testing. Okay, Python already sounds like a perfect thing for this. Currently doing everything manually, copy and pasting from my Excel spreadsheets. Any advice on learning how to create Python scripts to parse Excel spreadsheets? Yes, watch Wednesday. On Wednesday we are doing scripting with Python, and a couple of the examples are literally doing things that are very similar to that. Python is excellent for dealing with transformation of data like that. Simplifying the management of data and combing through tables and things like that, and combing through different data types and styles. for these spreadsheets. It's really good for parsing those things, especially if you can, like export it to CSV or something. So Africoder called it perfectly. Like being able to, do stuff with CSV is very easy in Python, and we'll be doing that exact thing on Wednesday. Great question. Excel, cool. Pandas is great. So we have that here. So we were able to open, and this was we were able to get this in. So it did not error out. We were able to consume it and check on the type, and check on what is actually in that variable. The code is the same as above. So these two things are the same thing by default. So let's go next. Open the file on a server. Oh, yes. So, perfect. This gives us a little bit more about what to do. So the open function returns a file object. We have not talked about objects yet. Objects are very important. A lot of things in Python are objects. Almost everything in Python is an object. Python is an object-oriented programming language. This will become important to you very, very soon. Open returns a function or a file object, which has a read method for reading the content of the file. So remember, it returned this weird thing here that you've never seen before. But again, what if you wanted to see this thing? It has a method called read that we can use to actually read it. So we can use this .read method to read it. So let's add that into our code so we can read it here. And so it will basically be list of names. Again, .read, open, close. And now let's check that out. And now we still are printing out the type, but we're reading what's in this object here. And so it spits it out here. So this is everything that was in that text file. So how can we confirm? If we cat names.txt, spits everything out, and look at this list. It's exactly the same. Starts with James, Tom in the middle, Anna at the bottom. Starts with James, Tom in the middle, Anna at the bottom. Great. This is good. So we now have the ability to consume a text file. And so it does not need to be a .txt file. You can consume other things, different data types, may need different packages or libraries to be able to manage them properly. But any text file you can just kind of pull in, and now you can use that accordingly. And so you can read just parts of the file, but that's not important right now. This one is good. So there's other methods as a part of this object. So we did a read. It went through and it read everything, but we could also do a read line. So you can return one line by using read line. If you wanted to just return that, you can read the first two lines by doing read line, it'll go down. So read line is something that you may need to use one day. Or you can do, you can read the whole file line by using a loop. That's interesting. I actually didn't think, actually, no, I didn't know. I knew that worked. So the same way that we did read there, that read, you can also do it this way. If you want to read everything in a file, you can say, for lines in, or for names, you can call it anything, for names in list of names, go ahead and print out, or name and list of name, go ahead and print out name. So this will iterate. So this is an object. This open does create an object. When you open up the file, it creates an object, and that object is iterable. You can't iterate through it. So you can use a for loop to go through the items that are in there. And if you do that, and we also run this again, you can see it goes through and it prints everything out with a new line. That's because everything in this file has a new line. So it's hitting everything here. We could do some other stuff to make that cleaner. But yes, you can go through these things and print them out. Because we can go through them and print them out, that also means we can do other things with them, which is great. So you can already start to see how you can kind of create automation by being able to, pull in files, pull in information, consume information from external file. We can pull the data in, and then we can use the Python that we know to, either manipulate that data or process that data how we'd like. And again, we're going to be doing a lot of that on Wednesday. So I'm not going to go too deep into that tonight. Let's go through the rest of the file handling stuff first, because this stuff is important. So we know how to read a file. We know how to, to grab an outside file and get that information into our Python code using the open function and either the read or, looping through to be able to print those things out if you need to do that. But it's good practice to always close a file when you're done with it. So we opened it. You should go ahead and you should close it when you're done with it. So just good practice here. Yeah, so it says, note you should always close files in some cases due to buffering changes. Made to a file may not show up until you close the file. This is not always an issue. Like, not closing a file isn't the end of the world, but it is good practice. You should absolutely close a file always. But it matters more again when you're doing things like automation, things on a server. A lot of times your computer will handle this fine. If you're doing some things, like locally to do some automation, maybe you're, I don't know, you're doing some type of weird task that throws stuff into a file or something, I don't know, processes things on your computer daily. It'll probably handle this fine without a close, but you should put the close in there. So we opened it. Let's go ahead. We're done with it. Finished everything off, and just like they have here, after we do everything we need to do, we'll go ahead and close it. So now we can just list the names.close. So we have an open function and a close function, all good. And this won't really show you anything. Opened it, we closed it, really nice. Again, sometimes that buffer on the computer will cause some problems if you do not close it. So open a file, you can read it, you can close it when you're done with it or when you're done doing whatever you need to do with it. Now, that's opening and consuming a file that already exists. Close files as soon as you're done with it. Yes, as soon as you're done with it. Don't do a bunch of stuff in between. Like, as soon as you're done using it, you should go ahead and get it closed. So you did see in the code how there's nothing else in here, but as soon as you're done using it, go ahead. Oh, actually, I see what you mean. You can close it right here. I see what you mean. Whoa, undo. Because I'm saving this to a variable, all that stuff's already in there, so I can close this file right here. And everything works just fine. Yes, 100%, you guys are right. Just like that. So as soon as you're done, whoops, IO, does it not work? IO operation on close file. Name in. Interesting. You can close it. This is why I use the with keyword. Like the contents in var. Technically, it is in. Gotcha. Yeah, it is in memory. Yes. There are ways to handle this better. I'll show you guys an example of that in a second. Let me go to the last. Let's get to the right, and then maybe we can create a whole little thingy that does everything all at once so that you could do that. Probably another var, you're right. Yes. Correct. So let's learn how to write this file. So we learned how to consume files that already exist, open them and close them. But now, how do you write a file? So you can use the open function. Remember those parameters that can be passed in to you, like with the open function, you can pass in the append or the write. Again, this will allow you to put information in a file. This is how you can write to an existing file. But again, both of these will actually create a file if it does not exist as well. So you can use that to create it. Yeah, so let's do that really quick. So let's look at their example. They open up a file. So they open up demo file2.txt. And they open it up in append mode. So it's going to add, because they're talking about existing files here. So they're going to be appending to it. They're going to be adding to the end of this file. And so they're going to use the dot write. After that write, they're going to write this string in there, and they're going to close it. Open and read the file after appending. So then they're going to open it and read it, but they don't tell us what's in demo file 2.txt. Let's run this example. Oh, they just ran it. Files for testing purposes. They don't show us what's in demo 2, so that's annoying. Cool. So let's go ahead and let's do this same thing. So let's say we want to add a name. Let's not close this yet. Let's say we want to add a name to this. So we want to append to name.txt. So we're going to go ahead and add in the operation that we want. So we want to append, and let's go ahead and let's go to names.write. We're gonna add Larry Berry to the end of it. All right, so let's make sure this matches up to what they have. So we're gonna do f.write to go ahead and write to this file, and then we can go ahead and close it if we'd like. Well, we should close it. All right, so currently Larry Berry is not in that file, and we can cat names.txt. Larry Berry is not in here. And if we run Python app and then we cat this again, we now have a Larry Berry right here at the end. So with this code, we were able to open up the file in append mode. So again, those modes are important. And we were able to write Larry Berry to it, and then we were able to close it. So good, all good there. Hopefully we're golden on that front. So that's how you write to a file. Let's go to creating a new file. So again, the X is the default create, but the A and the W also both do that. So actually, let me show you this real quick. Let me show you the difference between A and W for a second. Let me copy names to names.backup. I'll go ahead and back this up. And let's go ahead and let's change the mode. Change the mode from A to W and see what happens. And let's change it from Larry Berry to Larry Wary. All right, we changed the mode from append to write, and let's see what happens when we run this now. Python 3 app.py. So it went ahead and it did what it needed to do. And when we cat names.txt, it now only has Larry Wary in it. So be careful when you're using write versus append. Again, this is actually the same thing as the when we learned this is not the DevOps one, but in Linux there's some operators where I could echo Larry, and I could do a double thing here, which is append, and I could put that into names.txt. And if I cat names.txt, now it stuck it over on the end. It didn't give it a new line, but it stuck it on the end. But if I put this down to 1, it writes instead of appends. Write overwrites the whole file basically. So, and you can see here it just sticks Larry in here. So be careful when you're using write versus append. Again, appending adds it to the end. So it adds onto a file. Some people think about A as add, and write will just overwrite everything that's in there. So be careful when you're doing that. So just a thing to note, very important, very, very important. All right. After that, we have, let's see. So we can write or append, we can create a new file with X, but both A and W work if the file does not already exist. And the create will actually return an error if the file does already exist. So let's say we just want to create a Let's change this to X. And we don't need these right now. So let's go ahead and comment these out. All right, so we want to create a file called names.txt. So we can use Python to do that, to open up an empty file. So we run it. And we get an error. We get a file exists error. And again, that is because this file already exists. If we made it a name that does not exist, and we made it names2.txt, we change the name of the file, and we run it once, and we do not get an error. And if we look, this file is created, and it is in fact empty. But if we run it again, it will give us an error. So you got to be careful with that, just knowing that you can only create a file that does not already exist, and it will cause an error if the file does already exist. So just be careful with that. But also append and write will work the same way. If that file does not exist, it will go ahead and it will add that. So that is important to know. And then you can delete files. So to delete a file, you must first import the OS module. So we just learned about modules. So it already is immediately applicable to the things that we want to do. So yes, you can create files pretty easily, but if you want to delete a file, you actually have to use this OS module. OS stands for operating system. So it allows you to interact with your operating system. So os.remove, we need to first import it. So you can see here they have import OS, and then they're saying os.remove the name of the file. So if I want to do something, I can do something like this. You can check to see if files already exist. You can either try. So let's just use this is not how I would do it, but let's say we wanted to create a file. We could check this. We could do this. We could try to create it first. And because this file already exists, this will give us an error right now. But what we can say is, all right, go ahead and try that. But if it does exist, we can do OS. Well, let's import OS first. Actually, import it. Import OS. And if it does already exist, go ahead and do an os.remove on names.txt. Names2.txt. So what we've now essentially done is we've now put in code. We know that the create, the X stands for create. This will try to create a file named names2.txt, but it will return an error if that file already exists. This will allow us to attempt to create it, but if an error is returned, we can go ahead and we can remove that file. So that file is then deleted. We can go ahead and delete it. And then we can re-add it if we want. You shouldn't do this. This is not what you should do. But the paradigm is something that you could do for sure. Not a big deal. But we're going to go ahead and we're going to remove it and re-add it. So names2.txt. Let's run it. So do an LL. Take a look at names2.txt here. Let's fill it with something. Vim. Let's put some stuff in it so that it is different. All right, so now it has some stuff in it. Names2.txt, you can see it's no longer 0 bytes. We cat it, it should have everything that we just put in there. But if we run our code again, remember, what is our code trying to do? Our code is trying to create a file. But we know that it cannot create a file if it already exists. So then if it will get an error, that error should delete the file and create a new one, which should be empty. So if we run this again, you see we get no error. But if we look at this again, names.2 is empty again. And if we cat it again, there's nothing in it. So you can use, this is how you can use the things that we've done tonight to control kind of the flow. And so we just use the os.remove to remove that file and recreate it. Here, again, not a paradigm that you would want to do, obviously, because will depend on the situation, because you can see here we're deleting stuff that that we may not want to delete. So you can be careful with that. But this is a little bit of how you can string some of those things together to be able to make stuff happen. Again, a lot of times what you'll be doing with these file operations is you'll be processing data, you'll be taking in information, processing that information, and either delivering some type of output file or some type of logs or something like that for you to be able to consume and know what's going on, or just as output. So like one of the common things that we just did with Python where we had to use exactly these file handling commands is we were migrating a bunch of data from an older system with a different format. We were basically pulling all that in and we were formatting it, moving things around, a lot of information for the new system to be able to push that stuff into the new system. And we had to generate some output files so that we could, have the new system consume those output files. So you could do exactly that. Maybe you have a list of a bunch of people's names and birthdays and emails in a very weird structure, but maybe you're setting up a new system. Maybe you've built a new system to kind of handle how you're managing your contacts or something. You can write a little Python script to consume that data, transform it how you want, get it in the format that you want, and you can write it to a new file in the format that you would like to make things a little bit easier. So you can also do stuff for like folders and stuff here, but this is great. Why is this great? This is one of the biggest reasons why this is a good reason why people use Python in DevOps or systems administration type things to manage systems. It's great for systems automation because of the easy access that it has to the operating system file system. So it's great. It's a little more difficult in other languages. So it's really great, really easy. A lot of people do a lot of their automation that they would do in like Bash. They do it in Python instead because you do have a little more flexibility. Again, with the way that Python handles objects, it's a little bit easier sometimes to get certain things done. So that is what we have here. So excellent. That's everything for tonight. That was a lot of information. Definitely a lot of information because it was completely different kind of pieces of information. We learned tangible takeaways. We learned about modules. So we learned about these, separate pieces of code, separate files or libraries of code that you could import into your own code to be able to go ahead and use. And you can access those things. They can be variables, they can be functions, they can be classes, they can be methods, things like that. And the way that you use those is through dot notation. So if my module is called module, I can call it, I refer to the variable that I need. If the variable is name, I refer to it as module.name. So that's great. So we can import other code to be used elsewhere. We learned about errors. We learned that errors give you information about what's going wrong with your code. We learned about two different types of errors. We learned about syntax errors, which are things that go against Python's structure or its main syntax or structure or the rules that it has available to it. And we learned about exceptions, which are kind of runtime errors, which, they're syntactically good, but when they go to run real time, you run into a problem. And so we learned about how to handle those exceptions. We learned about the try except block, where we could try to run a piece of code. If it does not work, if it returns an error, we can go ahead and take action against those things. We also learned that we can ourselves create scenarios in which errors are generated. We can check for certain things, using our conditionals, using our comparison operators to go ahead and create these things. And then we learned about file operations. So we learned that we can, read files. So we can open up and read files. We learned that we can, go through those. We can iterate through those because they're objects. So we can use things like for loops to go through and do things with those files. We also learned that we could, write to files. We learned about appending versus writing. So adding to the end versus overwriting the whole thing. We learned that creating empty files can give us errors and that we can, use the things that we learned earlier with error handling to take action against those things. And we learned that you can, do some of those file operations using, or you have to use the OS module, the operating systems module, to be able to do some of those things with files. on the system. So a lot of different things tonight. Definitely, let me send over this because I do think you will I think you should keep this readily available to you because again, file operations are powerful and we will need to use these on Wednesday for sure. We'll be doing a lot of file operation stuff. We're going to be reading in files. We're going to be doing a bunch of cool stuff. Yeah, and I think that's it for tonight. Does anyone have any questions about anything that we went over this evening? That was, I don't know, it felt like a lot, even though we're done kind of right at 10, that felt like a lot. While I'm waiting for any questions, I want to go back to, someone brought up Fabric. Amir, I don't know if you're still on, but you brought up Fabric earlier. So we're getting into the, for anyone who's a part of the DevOps course, we are getting into infrastructure as code next week. We're getting infrastructure as code on Sunday for the DevOps bootcamp. And so if anyone is interested in learning how to manage infrastructure, if anyone's coming from the DevOps side of things, there were definitely some DevOps questions tonight. Fabric is a configuration management, at least from what I remember about it. It's a configuration management tool that is written in Python, so you can use it to configure systems. You can use it to configure, to basically declare the configuration of a machine, and you can use that to get it all set up. It's really nice. Fabric is cool, definitely cool, but it's definitely on the, if you're looking to, at least in the US, if you're looking to get a job in the DevOps space, Fabric's not heavily used. It's definitely it's on the bottom end of the configuration management options. Again, it kind of goes. Probably number one is probably Ansible right now. At least it's probably Ansible, probably then Puppet, then Chef, then SaltStack, then something like Fabric. I think that could be switched up from what I know. I do believe Ansible is first now. I don't know, but something to check out. But if you're learning Python, it may be pretty good. Maybe pretty. It might make it easier for you to hop into the configuration management realm. Ruby Junkie. So yeah, Chef. I like Chef. Chef is the second. I prefer Chef over Puppet. I prefer Ansible over Chef. But I do like Chef a lot. But again, I'm at the point now where I actually prefer to not do any type of runtime configuration. Do it all at build time. Through Packer or something, if possible. Yeah. So I don't know. If I can avoid it, I will avoid doing any type of configuration management, period. But cool. You require dependencies. Yeah, for sure. But cool. That's it for tonight. I don't see a bunch of questions, so I'm going to use this opportunity to get out of here. And again, I said I had a lot of stuff to do. I did not finish up everything I needed to finish up last night. So I will give everyone their evenings back. Thanks for tuning in tonight. Thank you for another great stream. Again, if you're interested in DevOps, DevOps Bootcamp, tomorrow we are doing a serverless lab. We just learned a lot about Amazon Web Services. We're going to be doing a serverless lab, a checkpoint lab. This might be the most relevant to anyone who is just here to learn how to code. This serverless lab probably is the most relevant to you because the serverless stuff is kind of made for developers and kind of learn about APIs and stuff. So we'll be doing that tomorrow. So if you're interested in that, check that out. And then here on Python, the Python Bootcamp, we will be learning about scripting next time. We talked about that already. So we'll be doing a scripting lab on Wednesday. So definitely stop by to check that out. Absolutely, ZZ. Thanks for tuning in. I love to share, love to have fun with you all. Love to learn together. Again, you guys teach me something every night. Again, like the import stuff that I learned tonight was good. Always adding to my skills as well. All right, everybody, have a great night. I will see everyone tomorrow or Wednesday. Cool. Peace.